To deploy artificial intelligence in an enterprise setting, you have to reconcile two opposing forces: the inherently non-deterministic nature of a foundation model and the rigid data governance required by regulatory bodies. You are attempting to build a deterministic fence around a probabilistic engine. This framework starts with the AWS Shared Responsibility Model. It defines the specific division between infrastructure protection and customer-driven data configuration. AWS takes responsibility for security of the cloud. This covers the physical servers, the global networking facilities, and the hypervisors that run managed services like Bedrock and SageMaker. You, the customer, manage security in the cloud. This includes the lifecycle of your data, identity access management, and the internal configuration of your virtual networks. Your specific share of this burden is variable. It shifts depending on the deployment scope your organization chooses. Operating in Scope 2 using an enterprise application like Amazon Q requires only basic identity management. The underlying model and infrastructure are managed for you. This matrix illustrates the transition. By the time you reach Scope 5, where you are training custom neural networks from scratch on SageMaker, you assume the maximum operational load, including full infrastructure isolation. Defining your exact position on this matrix is the first step in the design process. You cannot build a compliant system until you identify the specific assets you are responsible for protecting. At the application layer, text prompts act as executable code payloads. This interface provides a direct path for users to influence the model's internal logic. This creates a vulnerability to prompt injection and hijacking. An attacker can embed instructions within their input to override your system guidelines and force the model to perform unauthorized actions. We see this in jailbreak attempts, like this persona-based template. The attacker tries to bypass safety filters by creating an ethical justification for a full database dump. If successful, these hijacks can lead to prompt leaking. In this SQL payload response, the model inadvertently reveals internal database versioning and metadata that should remain hidden. To prevent these exploits, we deploy guardrails for Amazon Bedrock. This serves as a dedicated firewall at the application layer. Guardrails inspect every token of the input and output. They sanitize the data in real time, ensuring that both the user's request and the model's response stay within your safety and topic boundaries. This mechanism functions as a protective shield. It intercepts and filters payloads at the boundary of the model. When a violation occurs, the system executes a deny action. As shown here, it blocks the content and can redact sensitive information, such as PII, before it ever reaches the user. Securing the prompt layer ensures that the model's probabilistic responses are contained within a rigid, enforced operational area. Beyond external attacks, we must address the internal integrity of the model. Fairness and transparency are properties that must be engineered into the pipeline. SageMaker 𝗘𝘀𝘁 provides the tools to evaluate models for bias, accuracy, and toxicity during the training phase. 𝗘𝘀𝘁 identifies data skew, such as demographic imbalances, that would lead to discriminatory outcomes if the model were deployed as is. This interface allows for continuous monitoring in production. It tracks statistical drift to ensure the model remains reliable as real-world data evolves. When bias is identified, SageMaker Data Wrangler can mathematically balance the dataset, either by adjusting the weight of specific groups or generating synthetic instances. Responsible AI requires moving from black box deployments to auditable pipelines where data health is managed as a technical requirement. At the infrastructure level, the goal is to keep proprietary data off the public internet. This is a non-negotiable requirement for enterprise security. All compute and training instances are placed inside an Amazon VPC. This private network boundary isolates your resources from external traffic. We enforce zero egress by ensuring the subnets have no routes to internet or NAT gateways. In SageMaker, we can activate network isolation mode. This physically blocks the training container from making any outbound network calls. However, an isolated container still needs access to training data stored in Amazon S3. We resolve this using AWS Private Link and S3 gateway endpoints. These route traffic privately across the internal AWS backbone, connecting your isolated subnet to your storage without ever touching the internet. VPC endpoint policies provide the final layer of protection, enforcing resource level limits on these private connections to ensure data only moves to authorized buckets. This topology creates a closed loop, It secures your intellectual property by eliminating the network paths required for data exfiltration. A secure architecture is only verifiable if it produces an immutable ledger. You must be able to prove compliance to an auditor with objective data. AWS CloudTrail records every API transaction in the account, from model invocations in Bedrock to configuration updates in SageMaker. AWS Config continuously evaluates your resources against your security policies, flagging any non-compliant infrastructure changes as they happen. These tools work together to create a comprehensive governance layer across your entire AI environment. This data allows organizations to map their technical controls to global standards, like NIST, HIPAA, and GDPR. Understanding these governance frameworks is a core component of the AWS AI Practitioner certification. Constructing this environment requires the coordination of 3 distinct layers: prompt-level guardrails, isolated network loops, and continuous audit trails. Predictable model behavior is a result of these architectural limits. By engineering these specific boundaries, organizations can transition from experimental models to production-ready AI with their data integrity intact.